Let me start by asking a question. Do you think it's important for children to learn to write? It seems obvious. On the other hand, most people do not grow up to become professional writers or professional novelists or journalists. So if people aren't going to become professional writers, why do we need to teach them to write? Now, of course, there's many answers to this. We use writing in our everyday life. Writing helps us think about things in new ways and understand the world in new ways. So we don't learn to write just because we become professional writers, but because it's useful to us in all aspects of our life and ways that we see the world. In my presentation today, I want to make the argument that we should see computer programming or coding in exactly the same way. It's certainly true that most people will not grow up to become professional programmers or professional computer scientists, the same way that most people do not grow up to become professional writers. But the same way that writing can be useful to everybody in all aspects of life, I think the same can be true for computer programming or coding. The coding isn't just something that can be a pathway to job and career, although of course it can be very good for that. That there's a lot of statistics showing that the demand for computer programmers will be much greater than the supply, so there are good career opportunities. But that's not the main point that I want to talk about today. I want to try to convince you that coding is something that can be useful in everybody's life, the same way that writing is. That coding can be useful in practical ways, and also in helping all of us be able to organize our ideas and to see the world in new ways. It's sometimes said that we don't just learn to write, we write to learn. That by learning to write, we also are able to learn many other things. That as we write, we see the world in new ways, we learn in new ways. And I believe that we should not just learn to code, but code to learn. The one reason it's important to learn to code is not because of the job possibilities, but because coding enables us to learn new things and to see the world in new ways. Now, when I think about this, I see coding as providing people with the opportunity to really be fluent with new technologies, to really be able to express ourselves with new technologies. And actually, this is different than the way that most people today use computers. Because when I talk about fluency with new technologies, some people might argue, well, but most young children already have a fluency with the technology. Many people have heard the phrase digital natives. They say children today are digital natives. They already know to do many things with new technology. And of course, it's true that young people, many young people, are comfortable with new technologies, and they can do a lot of things with new technologies. But most of the time, many young people are there browsing and chatting and playing games. They interact with applications, but they are not designing, creating, and expressing themselves with technologies. And for me, I feel that if we really want people to be fluent with technologies, to be able to express themselves with technologies, that's when you really need to be able to program with new technologies, to be able to code. So I think I'll be arguing today on the importance of fluency with technology. It's not enough to be able to use technologies or interact with technologies, but in today's society, to be a full participant, you really need to have a fluency. It's not enough like when I come to Brazil, I know a little bit of Portuguese to be able to read a street sign, to be able to read a menu, but I'm not fluent, so I cannot really participate in society. And I think it's the same thing with computers. It's not enough just to be able to interact with the computer. You need a fluency to be able to express yourself, to get your ideas out to the world. I think in these ideas, I've always been very inspired and influenced by the great Brazilian educator Paulo Freire, who made a lot of the same arguments about reading and writing, the importance of being able to read the world and write the world, to be a full and active participant in society. You needed to be able to read and write and participate actively through your reading and writing. It's not just a matter of being able to read and write in a practical way, but to be able to be a full participant, to develop a voice in society, to be able to be a full participant in society. And in my mind, to be able to write the world today in today's society with today's technology means learning to code. I want to try to discuss these ideas by telling you a few stories that I've observed over the last few years. So I've organized my talk around 6 stories. And each of these stories talks about ways that young people have learned to express themselves and engage with the world through the ability of coding. I'll start with my first story. And the first story took place a few years ago in the month of May. And I know it was the month of May because the story starts the day before Mother's Day. And in the United States, Mother's Day is in the middle of May. Is there a Mother's Day here in Brazil? Is it also in May? Okay. So this happened, it was the day before Mother's Day. And I suddenly realized that the next day was Mother's Day, and I had not gotten any type of gift for my mother. So I started thinking, what will I do for my mother for Mother's Day? And I thought, well, maybe I could make my mother an interactive Mother's Day card using the new Scratch software that my research group has been developing. So Scratch is a programming language that allows you to create your own interactive stories and games and animations and share your creations online. So I thought maybe I could use Scratch to make an interactive Mother's Day card for my mother. Before starting, I decided to look on this online Scratch community to see if anybody else had made a Mother's Day card. So in the search box, I typed in Mother's Day to see if there were any other Mother's Day projects. And to my surprise, there was a long list of Mother's Day projects in the Scratch community. Many of them had been made in the past 24 hours by procrastinators like myself. So I decided to look at some of these projects. So I'll show you a few of the projects that I saw. So this is a simple animation with a cat and who's giving a special Mother's Day greeting to the cat's mother, and even offers a replay at the end. Always very considerate. So this was one way that a child, I think this was made by a 10-year-old girl who has made this as a Mother's Day card. The next example is an interactive Mother's Day card, whereas when you move the mouse, it changes the letters into words. And it changes Happy Mom Day into I love you and care for you, Happy Mother's Day, Mom. So it's a way the mother could interact with the Mother's Day card. It ends with a nice I love you. The last example is a story that someone created about how they came to make their Mother's Day card. So it says, press the space key to start. It says, hey, this morning someone told me it was Mother's Day. I Googled and found out it was true. Now I have something to say to you. I love you so much. This much. And ends with a picture of the family. So when I saw these examples, I was very happy to see these examples because I think these examples capture part of what we were hoping to see when we developed the Scratch programming language. Because I think these children are really becoming fluent with the new technology. They were able to use the technology to express ideas that were meaningful to them, They were personal to them. They really were able to share what they were thinking with someone else, which is part of what writing and communication is about. But instead of writing a traditional Mother's Day card on a piece of paper, they were using coding to make a special dynamic, interactive Mother's Day card. These children were also showing that they knew how to use the new technology creatively. They weren't just following instructions in order to make something happen on the computer screen. They were taking an idea and creating a project based on their own imagination. And I think nothing is more important in today's society than the ability to come up with creative projects. We know that we live in a society that's changing more rapidly than ever before. So today's children will grow up in a society where they constantly must come up with creative solutions to unexpected situations, because they'll always be confronted with new situations in a rapidly changing world. So if we want today's children to grow up as creative thinkers, to be able to thrive in today's society, we need to give them opportunities to create with new technologies, to develop as creative thinkers. And I think from these projects, we start to see how children are developing as creative thinkers, not just answering some questions or problems, but coming up with their own ideas and learning how to express themselves in new ways. Let me end by telling you about my own Mother's Day card. I'm sorry to say that I didn't end up making a Mother's Day card for my mother. Instead, I sent her links to about 10 Mother's Day cards that other people had made on the Scratch website. And my mother wrote back to me exactly as I'd hoped. She said, "I'm so proud to have a son that created the software that allowed all of these children to create Mother's Day cards for their mothers." So my mother was happy and I was happy, but even more, I was happy that all of these children were able to share their ideas and to be able to make a special connection with their mother through coding. Let me go on to story number 2. Story number 2 took place in an after-school community center called a computer clubhouse. It was mentioned in the introduction that our group started this network of clubhouses where young people from low-income communities can come to learn to use new technologies in creative ways. And I was visiting one of the clubhouses. It happened to be in Los Angeles. And I met a 13-year-old boy. Let's call him Andrew. And Andrew was using Scratch to make a game. And he was very happy with his game, and he showed me his game. So his game was something like this. This is the Scratch website right now. And in his game, if I can move the big fish, and I try to eat the little fish. So he showed me this project, and he was proud of it, and I thought it was a nice project. But he said there was a problem. He wanted to keep score in this project, that every time the big fish ate a little fish, that the score should go up by 1. And he didn't know how to increase the score or to keep score. So he asked me about it, and I showed him. Now, on the Scratch website, when you see a project, there's a place that says See Inside. If I click See Inside, I can see the code that's used to make the project. And in fact, here you see he wrote the code in English, but in fact, in Scratch, we can change the code to any of 50 languages. So in fact, I'll change it now. As you might see, actually, there's 2 Portuguese. There's Portuguese and Portuguese Brazil, because the translators in Portugal and the translators in Brazil could not agree. So we had to put in 2 translations. So this is Scratch in Brazilian Portuguese. And just to show you how the software works, like if I'm controlling the fish here, if I pull the block that says move 10 steps, when I click on it, the fish moves 10 steps. If I go to the category called looks, and I say, next costume, when I click on that, it changes the shape, and it opens and shuts its mouth. If I put the two blocks together, they snap together like Lego bricks, and they're able to move and change its costume. So in Scratch, you create programs just by snapping blocks together. So this is much different than the way people traditionally have written programs. Traditionally, people need to learn all sorts of special rules of where do I put the semicolon, where do I put the brackets and parentheses. In Scratch, we wanted to make coding as easy as building with Lego bricks. So Andrew at the clubhouse had learned how to do this, and these stacks of blocks, these are the rules for controlling the behavior of the big fish. There are also rules, these are the rules for controlling the behavior of one of the little fish. So he had learned how to put these blocks together to control the fish, but he wanted to know how could he keep score. So I showed him there's a category called data, and I told him there's something called a variable. And this is to create a new variable, and I give it a name. And someone told me earlier today I could use the word puntos for points. Hopefully that's a good translation. So now, it made extra blocks. Like this is a block that says, increase the score by 1. And if you look over here, you can see there's a little monitor that shows me the number of points. And when I click on this block, if I click on it once, the score goes up to 1. If I click on it again, the score goes up to 2. And I showed this to Andrew, and he immediately saw that if he put the block inside his program, right where the big fish eats the little fish, then the score would go up each time the big fish eats the little fish. So let me try this. I'll make it full screen. And now, whenever I eat a fish, it went up to 3, to 4, to 5. So he saw that it worked, and he was very excited, and he reached out his hand to me, and he said, thank you, thank you, thank you. And what went through my head was, I wonder how often students thank their algebra teachers for teaching them variables. Now, that generally doesn't happen. But here, he was thanking me because he really cared about variables. In fact, my guess is that Andrew had been taught about variables in school, and he hadn't really paid attention. Because when he learned about it in school, he saw no reason for learning it. There was no, he never found out why a variable might be useful. But now he saw that variables really could be useful to him, that he could put it to use in his Scratch project. So he was very excited about this. And I think this drives a lot of the work that we do in creating projects like Scratch. We feel it's very important to connect to the interests and the passions of the learners. Because we can see that when Andrew cared about variables, he was more ready to learn about them. And I have no doubt that he'll remember much more about variables because he used it in a situation that he really cared about and was meaningful to him. So we're always looking to see how can we bring new ideas into children's lives in a way that it connects to their interests, to their passions. This is one reason why for many years our group has worked with the Lego toy company, because we know that children love building things with Lego. So we've been extending the Lego construction kit by adding robotic elements so children can start building Lego constructions that come alive and move and interact and communicate. So with robotics kits like Lego Mindstorms, children learn advanced engineering and scientific ideas, but they learn about them in a context which is meaningful to them. This is one of the reasons why we call my research group the lifelong kindergarten group. But I've always been inspired by the way children learn in kindergarten. In kindergarten, children are given the opportunity to work on projects they care about. They might have in their mind the vision of a fantasy city, and they pull out the blocks and they start building the city. Or they might have an idea of of a story that takes place in an enchanted forest. And they'll bring out the crayons or finger paints and start making a picture of the enchanted forest. So children in kindergarten are creating things based on their own interests, and they learn a lot in the process. When they build a tower in the city, they learn about stability, what makes things stand up or fall down. When they're painting with finger paint, they learn how colors mix together. More generally, they learn how to work on a project, how to start with an idea and create something based on their own ideas. But after kindergarten, too often, education shifts. And as we heard earlier in this conference, the education too often shifts to a delivery model where just information is being delivered to the children. Or as Frary talked about, a banking model of just depositing information. So we want to shift away from that. We want to take the kindergarten approach and extend it to learners of all ages. And we think that new technologies can make this possible if we use them the right way. When I think of Andrew and his game, even though he was 13 years old, I see this as a kindergarten-style project. He was building his program by snapping blocks together, somewhat like kindergarten children. He was learning about variables and other mathematical ideas in a context that he cared about while working on a project, just like kindergarten children. But he was working on a more advanced project and learning more advanced ideas than you would ever learn in kindergarten. So I think if we use new technologies the right way, whether it's through robotics kits or programming languages, we have a chance of extending that kindergarten approach so that learners of all ages, whether they're 13 like Andrew, or 18, or 35, or 55, people of all ages should be able to continue to learn in this kindergarten style. Let me move on to my third story. And my third story focuses on the online community around Scratch. I think from the first two stories, you saw a lot about what young people can learn as they create with Scratch. They learn to think creatively, as we saw in the Mother's Day cards. They learn to reason systematically, as we saw in Andrew's fish game. At the same time, children, by working in the Scratch community, learn to work collaboratively, another essential skill for today's society. We saw that collaborative work was very important. So right from when we launched the Scratch software, we didn't just have an application for programming, we also launched an online community at the same time so that people could share their projects online. And this online community has been a very important part of Scratch, where children don't just create, but they share their creations. So there's an audience for their creation. And by sharing their creations, they get feedback and advice and suggestions from other people in the community. Also, as they look at other people's projects in the community, they get inspiration and they get new ideas of what they might create. So the online community serves as both an audience and an inspiration for people that are creating with Scratch. And the online community has continued to grow. There's now more than 5 million projects that have been shared in the online community by children around the world. Every day, there's 10,000 new projects shared by children around the world. Those Mother's Day cards and Andrew's fish game were just a few of the millions of projects on the online community. I'll now share a story that shows several of the projects from one member of the community. Her username is MyRedNeptune. Everyone in Scratch makes up a username. And MyRedNeptune joined the community when she was 12 years old. And I'll start by showing you one of the first projects that she created, which was a Christmas card that she wanted to share with some of her friends. You'll see as you click on each reindeer, it plays part of a Christmas song. So when we saw this project, I thought this was a very nice Scratch project. And it was nice how she both created it and then was able to share it with her friends, to be able to give them a Christmas card that she created with Scratch. So again, she was truly showing a type of fluency of creating things that were meaningful that she could share with others. But what really impressed me was what My Red Neptune did next. She didn't just create a card, but she then started thinking about other ways that she might use this online community. She decided that what she really enjoyed most was making individual animated characters. So she started creating projects that had collections of animated characters like this. It had flying horses and galloping horses and dragons and dinosaurs. And then she said, if you like any of my animated characters, please feel free to use them in your projects. If you want a different character, write a comment below and I'll make it for you. So she was offering her services in the online community, willing to make characters for other people. So she was basically offering her consulting services on the online community. And this is something we had never thought about when we created Scratch. So this was really a creative thinking that we saw on the Scratch community, of a young person thinking of new ways of using the community. And sure enough, other young people started asking her for animated characters. Someone was making a project where they wanted a cheetah, the large cat. So My Red Neptune went online, she found a video of a cheetah, and used it as a model for making an animation of a cheetah. Someone else asked her to make a bird with flapping wings. So she made a bird with flapping wings, and the person liked it, but then wrote back to My Red Neptune and said, well, that was a great animated bird, but I'd like to learn how to make that so that I could start doing it myself. Can you show me how you made it? So My Red Neptune made another Scratch project. There was a tutorial that went step by step and showed how she made the bird with flapping wings. This was something that we knew when we created Scratch, that our group at MIT would make some tutorials. We expected that some teachers would make tutorials, but we did not expect that 12-year-olds would start making tutorials. But My Red Neptune is not alone. There are literally thousands of tutorials on the Scratch website made by young people around the world. Some of them are about how to draw. Some of them are about how to program, like how to make a scrolling background in a game. Some of them are about how to make your projects popular in the Scratch community. So people are making tutorials of all sorts of different things. Members of the Scratch community are also collaborating with one another. So like here's an example. My Red Neptune teamed up with 3 other people, or 4 other people from 3 different countries, to make a collaborative game. So in this case, My Red Neptune made the characters, and somebody else did the music, someone did the background, someone did the story play. So again, she was really learning how to work collaboratively in an international scale while working on the Scratch project. So I think we see here the important social side of the Scratch community, which again, we see as essential for young people growing up in today's world. The ability to collaborate on projects and share ideas with others is a key skill for success in today's society. And we see how young people can learn that as they create and share Scratch projects. I'll go to my 4th story, is about Scratch in schools. The projects I've shown you so far were all made by children using Scratch outside of schools, in community centers like the Computer Clubhouse or at home. And in fact, when Scratch was first released in 2007, it first was used mostly outside of schools. But we know that it's very important for Scratch also to be used in schools to make sure it reaches a broad range of young people. If we really want to reach all young people from all different backgrounds, it's so important for this to be used in schools and to connect with across all the different possible uses in different disciplines. So I'll show you a few examples. And as we start to support Scratch in schools, we did not want Scratch only to be used in computer science class or computer programming class. Like writing, we wanted Scratch to be something that could be used in all parts of the curriculum. The same way that when you learn to write, you use your writing in all the classes. If you have a social studies report, you'll use your writing there. In science class, you write a report. So the same way you use writing across the curriculum, we wanted Scratch to be used across the curriculum. Let me show you a few examples. This is a project from a school in the United States where children were making book reports with Scratch. They were reading the book Charlotte's Web, and they made the project to tell about what they learned by reading the book. One reason I like this example is, in addition to learning programming, you can see they're learning about writing as well. They're writing about the story. Also, just as that pig becomes smaller, to make that happen, they're learning how to scale it. They're learning mathematical ideas about scaling to make the pig smaller. They're learning artistic ideas about perspective, of how things look as it goes further away. That as you work on projects, it cuts across the different disciplines. The next project is from a school in India, a school for very poor children in India. And when they were studying the layers of the earth, the children used Scratch to show what they had learned about the earth. So here, this is his own voice. It's a 13-year-old boy speaking in his native language of Kannada. And he's giving a guided tour of the earth, explaining what's happening in different parts of the different layers of the earth. His teacher told us that this boy was very fascinated by the fact that there were things moving inside the earth, like the water table, which is moving. So he has special sound effects when you get to the water table. He was so excited to find out and to tell other people about what's moving inside the earth. The last example is from a middle school where the students were studying the island of Rapa Nui, or Easter Island, off of South America. And whilst many of the students were just doing traditional reports, one student said he wanted to use Scratch to do the report, and he made a simulated version of Rapa Nui, somewhat like Sim City, but Sim Rapa Nui, where it was based on the culture and the history and the economy of the island of Rapa Nui. And he had learned that fishing was central to the economy. So in order to survive in this game, you have to make a fishing rod by cutting down a branch and then going fishing. But if you cut down too many trees, then that doesn't work either because it's bad for the environment. So again, he was showing what he had learned about the culture and the economy and the customs of Rapa Nui. So I think in here, we get to see how children can use these ideas that they're learning about Scratch, not just for learning to code, for a programming or computer science class, but using it as a tool to express themselves in all parts of the curriculum. So that's the part that gets us most excited when we see this happening, of trying to see how coding could be a basic type of fluency that you use both inside of school and outside of school and across all different disciplines. To support this, one of my students, Karen Brennan, created a whole website called Scratch Ed, Scratch for Educators. So there's now a whole online community of educators who are using Scratch. And on the Scratch Ed website, they share ideas with one another of describing how they're using Scratch in their classroom, what works, what doesn't work, how they're assessing Scratch in the classroom. So in addition to the community of young people who are using Scratch, there's also now a community of educators sharing ideas about how to use Scratch. My fifth story is a story that took place last December. I know I already today met with some teachers who participated in an event last December called Hour of Code. This organization, code.org, created this event called Hour of Code, trying to convince everybody to spend an hour learning a little bit about coding. And in fact, many people participated in this. And there were literally millions of people around the world starting to code. And the code.org website provided many different ways to get started with coding through Code Academy or Scratch or some special tutorials that code.org made. Let me start by showing you a little bit about what we did for Scratch. We encouraged people to make an interactive holiday card, and we made a tutorial to help people learn how to make a holiday card from scratch. I'll show you a couple examples of what children created. This was one that was created by some children in Boston at a community center.
Make my wish come true. All I want for Christmas is you.
I think what I really liked about this is how much the children put themselves into the project, using their own images, really make it personal. And again, being able to express yourself in a way that is meaningful to yourself and others is a core part of our approach to programming, where you make things, where you put yourself into the project. But at the same time, as they were sharing it, other people could look inside and see how they did it and learn how they created the project in Scratch. Let me show one more example. This one was made in Catalan. It was made in Spain. So it showed just the contributions from around the world. So I think you see from these examples the way they're very personal. Children able to put themselves in it, but in the process of creating these projects, learning some very important ideas. Now, I want to contrast that with some different ways of learning coding that, again, have their own values, but I do think it's important to think about different approaches. Not all approaches to learning to code are the same. On the code.org website, most of the ways of learning to code looked more like this, where it was giving you a puzzle to solve, and you basically had to put blocks together. So you're putting the blocks together, very similar to Scratch, in order to solve a problem. And again, I do think it can be very valuable to learn some things this way, and some people can be very inspired by puzzles. And in fact, when I was growing up, I loved to solve puzzles. But in my view, if we really want children to grow up to become fluent, to express themselves, we must give children the opportunity to make things personal, not just to solve problems that are given to them, but allow them to tell their own stories, to personalize to them in a meaningful way. I make the analogy again to writing. If we want children to learn to write, we would not just give them crossword puzzles to solve. There's nothing wrong with crossword puzzles. I like solving crossword puzzles. But what worries me is that too often the way that we introduce coding and many other mathematical and scientific concepts is we just give children puzzles to solve or problems to solve. We don't really allow them to become fluent. We do the equivalent of having them solve crossword puzzles. And again, nothing wrong with crossword puzzles, but we want children to grow up, if we want children to grow up fluent with new technologies, to be able to express themselves, develop their own voice, tell their own stories, we need to be able to introduce things in a different way to allow them to take their own imagination and share it with the world. Let me finish with story 6. This is a story about how we're now stretching Scratch in new directions. All of the examples I showed to now were about creating a Scratch project. There was a little multimedia rectangle on the screen. And we're now trying to extend Scratch in new directions, to stretch it off of the computer screen and connecting it to the rest of the other online activities. As a first example, let me show you an example made by a circuit board we created, a Scratch circuit board that allows people to build things in the physical world that interact with their Scratch projects. In this case, They built a physical saw that then is used to control the characters on the screen. It uses a light sensor to detect as they're moving the saw and makes the characters on the screen move as they move in the physical world. I think one reason I like examples like this is that if we believe that giving children the opportunity to design and create is important, this gives them two opportunities to design and create. They're designing something in the physical world, but also designing something on the screen and linking them together. So it's bringing together the world that they live in, the physical world, with the new virtual online world. I think there's lots of value to connect these two worlds together. Here's another example of a child that's using Scratch to connect with the Lego WeDo robotics kit. So in this case,
really responsible for
he made a driving game and then used sensors from the robotics kit to control the game. This is a tilt sensor. So as he moves and turns the steering wheel, it can detect the tilt, which controls the car on the screen.
When Martin comes, if you guys come up with
That's a distance sensor. And as he moves that, it can tell how far away it is. It controls the speed on the screen. So I think with these examples, you can see allowing children to build things in the physical world, build things on the screen, and bring it together opens up a new dimension of how children can express themselves and learn. Let me show a few live examples here of ways that we can use these new capabilities. Here's one I'm going to ask you to participate. This is a project that uses the microphone in the Scratch program. And as the program goes, the bat responds to sounds. Now you're going to have the bat eat the butterfly. You have to make more noise than that. So very good. So again, I think you see children play games like this all of the time. We want them to be able to create games like this. Give them the opportunity to create games that engage other people. Or here's one more example using one of the latest new features in Scratch that uses a camera. This uses the camera. As you can see here, there's Lego figures dropping down the screen. But if I now go into here, so children these days, they use computer systems like Microsoft Kinect, which allows them to be able to interact with the screen with their bodies, but they can't create their own. They just interact with things that someone else created. I have no doubt that the software designers that made the Microsoft Kinect games learned a lot in the process. I'm not so sure that children who play the Microsoft Kinect games learn very much in the process. It's when you're creating things is when you do the best learning. So we want to have children be able to make games like this is when they're going to have the best learning experiences. Let me mention one other way that we're extending Scratch. So these were extending Scratch to the physical world. We're also extending Scratch down in age. We're working on Scratch Junior for younger children. Scratch right now is for ages 8 years old and up, but we see that young children also should be able to tell their stories and create projects on the computer. So we're creating Scratch Junior on tablets for young people ages 5 to 7 to be able to program using a simplified version of Scratch with less language, more icons, simpler choices, but still the same computational ideas. The same core ideas that you're learning with Scratch, you learn while doing a Scratch Junior. And it prepares you to be able to continue to express yourself. And it lets children growing up to see the computer design that they can create with. These days, there's thousands and thousands of apps for young children, but generally young children just interact. They tap and they drag, they don't get to create. With Scratch Junior, we want to let young people create with a laptop, create with a tablet. I think with all of these projects, from Scratch and Scratch Junior to the robotics projects we've worked on, in all of these, we're trying to give a new vision of how children might learn with technology, and more broadly, how children can learn in all types of activities. We want to move away from the days where learning is seen as a delivery of information, and instead empower children of all ages to be able to continue to design, create, experiment, and explore. We know that in today's society, changing more rapidly than ever before, that success, whether it's for an individual, for a company, or for a country as a whole, will be based on the ability to think and act creatively. I really hope that we're able to work together on being able to help young people learn to code, code to learn, and most important, become creative thinkers so they can be full and active participants in tomorrow's society. Thank you very much.